Sum and difference formulas. This video is about sum and difference formulas for sine, cosine, and tangent, and evaluating trigonometric expression like sine of u plus v, sine of u minus v, and tan of u plus v. Sum and difference formulas. Sine of u plus v is sine of u cosine v plus cosine u sine v. Number 2, sine of u minus v is sine of u times cosine v minus cosine u sine v. Cosine of u plus v is cosine of u cosine v minus sine u sine v. And cosine u minus v is equal to cosine u cosine v plus sine u sine v. Tangent u plus v is tangent u tangent plus tangent v over 1 minus tangent u times tangent v. Number 6, tangent u minus v is tangent u minus tangent v over 1 plus tangent u tangent v. This is a review of Pythagorean identity and signs of sine and cosine function. Cosine square theta plus sine square theta equals to 1 has several useful forms. Sine theta equal to plus minus the square root of 1 minus cosine square theta. Now this plus or minus sign depends on the quadrant in which theta lies. If theta lies in quadrant 1 and 2, then sine theta is positive. If theta lies in quadrant 3 and 4, then sine theta is negative. Number 2, cosine theta is equal to plus minus the square root of 1 minus sine square theta. Sine depends on the quadrant in which theta lies. If theta lies in quadrant 1 and 4, then cosine theta is positive. If theta lies in quadrant 2 and 3, then cosine theta is negative. For a unit circle, for an angle theta, there corresponds a point xy on the unit circle with x equal to cosine theta and y equal to sine theta. So for example, we have angle pi over 3 and the ordered pair 1/2 comma square root of 3 over 2. So x is 1/2 and y is what? Square root of 3 over 2, and cosine theta is 1/2 and sine theta is square root of 3 over 2. Guideline to find exact values of trigonometric function. If the angle of trigonometric function is in the unit circle, then use the unit circle values, because if you use calculator you will get an approximate result and it will be completely wrong. If the angle of trigonometric function is not in the unit circle, then write the given angle as sum or difference of two angles which are in the unit circle. Then use the property sum or difference formula to write an equivalent expression, and use the values from the unit circle and simplify. Here is an example 1. Find the exact value of the trigonometric function sine u plus v for the given angle sine u equal to 12 over 13, where u is between 0 and pi over 2, and cosine v equal to minus 3 over 5, where v is between pi over 2 and pi. So first find cosine u using sine u equal to 12 over 13, where u is between 0 and pi over 2. Since u is between 0 and pi over 2, u is in quadrant 1, and in quadrant 1 all trigonometric functions are positive. So cosine u is also positive. So use the Pythagorean identity cosine u equals to square root of 1 minus sine square u. Now I substitute sine u equals 12 over 13 here. So this becomes square root of 1 minus 12 over 13 square. So now simplify, so it will be 12 square will be 144 and 13 square will be 169. So you have a square root of 1 minus 144 or 169. Now we rewrite 1 as 169, 169. And now we can subtract. So 169 minus 144 is 25 over 169, and now it's square root. If we take the square root, 25 Square root of 25 is 5. And the square root of 169 is 13. So sine u is equal to 12 over 13 given. Using this identity, we found cosine u equals to 5 over 13. So now we're going to find sine v using cosine v equal to minus 3/5, where v is between pi over 2 and pi. So in quadrant 2, sine is positive. So we write the Pythagorean identity sine v equals to square root of 1 minus cosine square v. Now we substitute cosine v equal to minus 3 over 5. So this becomes square root of 1 minus square of minus 3 over 5. So now we copy the square root of 1 minus 3 square is 9, 5 square is 25. So in order to subtract, we convert 1 into 25 over 25. So now we can subtract 25 minus 9 is 16. So we have square root of 16 over 25. Now square root of 16 is 4 and square root of 25 is 5. So knowing cosine v equal to minus 3/5, we found sine v equals to 4 over 5. So now when we use the values of sine v equal to 4 over 5, cosine v equal to minus 3 over 5, sine equals 12 over 13, cosine u equals to 5 over 13 to answer the question as well. So since we have to find sine u plus v, so we're going to write sine u plus v as sine u cosine v plus cosine u sine v. Now we substitute the values of sine and cosine. So sine u is 12 over 13 and cosine v is minus 3 over 5 plus we have a cosine u is 5 over 13 and then we need a sine v and sine v is equal to 4 over 5. So this becomes 12 times negative 3 would be negative 36 and 13 times 5 is 65 plus 5 times 4 is 20, 13 times 5 is 65. Now they have same denominator, so we write 65 and add these two numbers. So minus 36 plus 20 equal to minus 16 over 65. So here's example 2. We're going to find the exact value of cosine u plus v for the given sine u equals to minus 12 over 13 and cosine v equal to minus 3 over 5, where both u and v are in quadrant 3. First find cosine u using sine u equals to minus 12 over 13, where u is in quadrant 3. And in quadrant 3, cosine u is negative. So by Pythagorean identity, we use cosine u equal to minus square root of 1 minus sine square u. So now we substitute sine u equals to minus 12 over 13 here. So this becomes negative square root of 1 minus square of negative 12 over 13. So now we're going to simplify. So minus square root of 1 minus square root of 12 is 144 and square root of 13 is 169. So in order to subtract, one has to be rewritten as 169 over 169. And now we can subtract 169 minus 144 is 25 over 169. So that's the square root of that. Now square root of 25 is 5 and square root of 169 is 13. So we have found cosine u equals to minus 5 over 13. So now second, we're going to find sine v using cosine v equal to minus 3 over 5, where v is in quadrant 3. And in quadrant 3, sine is also negative. So from Pythagorean identity, sine v equals to minus square root of 1 minus cosine square v. So we substitute cosine v equals to minus 3/5. So this becomes minus square root of 1 minus square of minus 3 over 5, which is equal to minus square root of 1 minus. Now 3 square is 9 and 5 square is 25. So now in order to subtract, we have to rewrite 1 as 25 over 25. So now we have minus square root of 25 over 25 minus 9 over 25. So we can subtract 25 minus 9 is 16 over 25 square root and minus. Now square root of 16 is 4 and square root of 25 is 5. So you have a negative 4/5. Sine v is negative 4/5. And cosine v was given negative 3/5. Now we will use the values of sine v equal to minus 4 over 5, cosine v equal to minus 3 over 5, sine u equal to minus 12 over 13, cosine u equal to minus 5 over 30 to find the values of cosine u plus v. So first we write some formula for cosine u plus v. Cosine u plus v is cosine u cosine v minus sine u sine v. Now we substitute cosine equal to minus 5/13 and cosine v is minus 3/5. So this becomes cosine u becomes minus 5/13, is a minus 3/5, minus sine u is minus 12 over 13, and the sine v is negative 4 over 5. So now we multiply these two. It will be positive 15 over 65, minus will be 48 over 65. Now we can subtract. So it gives you negative 33 over 65. So here's example 3. Find the exact value of trigonometric function and the u plus v. For given sine u equals to minus 12 over 13, we use between pi and 3 pi over 2. And cosine v is negative 3 over 5, where v is between pi over 2 and pi. So solution, find tangent u using sine u equals to minus 12 over 13. And sine u is defined as the opposite of hypotenuse. U here is between pi and 3 pi over 2. And we find tangent u as follows. Set up right triangle for angle u in quadrant 3. Because that's the quadrant 3. That's where you set up. So you draw the hypotenuse and this one. So this opposite side would be negative 12 and hypotenuse 13. Now this is adjacent since it's to the left side of y axis, so it should be negative. So adjacent will be negative square root of 13 square minus square root of negative 12. So that becomes negative square root of 169 minus 144. When I subtract 144 from 169 becomes 25. So you have a negative square root of 25, so which will be negative 5. So now triangle is complete. So from this triangle we can find tangent u, opposite over adjacent. Opposite is negative 12 and adjacent is negative 5. Both are negative, so it becomes 12 over 5. So now we find tangent v using cosine v equals to minus 3 over 5. Where v is between pi over 2 and pi, and that's quadrant 2. So we set up a right triangle for angle v in quadrant 2. So adjacent is negative 3 and hypotenuse is 5. And this came from this. And we have to find the opposite, which is basically 5 square minus square of minus 3. So 5 square is 25 and square of minus is 9. So 25 minus 9 is 16. Square root of 16 is 4. So now it's a complete triangle. So tangent v is opposite of adjacent, which is 4 over negative 3, which becomes negative 4 over 3. Now we use tangent u is 12 over 5 and tangent v just found negative 4 over 3 in this formula. Tangent u plus v equal to tangent u plus tangent v over 1 minus tangent u tangent v. So we have a tangent u plus v is tangent u plus tangent v, or 1 minus tangent u tangent v. So we're going to substitute tangent u is 12 over 5 and tangent v is negative 4 over 3. So this becomes 12 over 5 minus 4 over 3. 1 minus 12 over 5 times negative 4 over 3. So in order to subtract these two, we have to find the LCD, and we convert, multiply 12 with 3 and 5 with 3, so we become 36 or 15. And to make 3 is 15, to multiply 5 with 4 and 3 with 5, so we become 20 over 15. On the bottom we have 1, negative 12 times negative 4 will be positive 48, 5 times will be 15. Okay, so we can subtract 36 minus 20 over 15, and in order to add this two, we have to rewrite 1 as 15 over 15. So now we have 36 minus 20 is 16 over 15, and the bottom we have a 15 plus 48 over 15, which becomes 63 over 15. So now we can write 16 over 15 times reciprocal of 63 over 15, which becomes 15 over 63. 15 cancel, so the answer is 16 over 63.